Good morning. I would like to welcome you all to today's webinar organized by the Watson Project. My name is Dimitrios Argyropoulos, professor at UCD at University College Dublin and project coordinator of Watson. Watson is an Horizon Europe project with 47 partners across 20 countries, aiming to tackle food fraud, ensure food authenticity, and enhance food traceability using its comprehensive digital framework. Today, we will be exploring together the following questions. How can we reduce fraud in food supply chains? What technologies are already helping us to do it? And how can we make our food systems more transparent, traceable, and trustworthy? During the webinar, you will hear directly from our Watson experts working in 3 different supply chains, mainly dairy, wine, and white fish. Each of them will present practical examples of how the Watson technologies and methods are being used to expose and prevent fraud. Specifically, we have organized 3 different talks. First one on improving the traceability of high-value products in the cereal and dairy chain in Finland, traceability for enhanced knowledge in the Portuguese wine value chain, and last but not least, combating white fish counterfeiting in Norway. Hence, I would say that today's webinar is a unique opportunity to learn about the tools and strategies being applied in different agri-food sectors and to understand the specific challenges and solutions associated with each. Before we move to the speakers, few words about housekeeping. First, webinar recording. The session is being recorded and it will be posted on the Watson Project website and social media shortly after the event. Please turn off your camera and mute your microphone. Use the chat function and we will address your questions and comments during the question and answer session. And there are also captions if you need available. Kindly click on more and then language and speech where you will find an option to turn on automated captions. Our speakers today, Anna-Lina will kick off, a senior researcher at VTT in Finland. Then we will move to Pedro, another senior researcher at Inesc in Portugal. And we will conclude this webinar with Truls, who is a senior researcher at Sintef. I would like now to hand over the moderation to my colleague John, and also to kick off the webinar with the first speaker, Hanna-Lina. The virtual floor is yours. Thank you all for participating and enjoy the webinar.
Thank you, Dimitrios, for the introduction. And good morning to everybody. I will be talking to you about the Finnish pilot in the Watson project, and this is related to improving the traceability of high-value products in the cereal and dairy chain. And in this pilot in Finland, there are 3 Watson project partners involved. There is Upcode from Vaasa. They have been developing the technology that I will be presenting in this presentation, these smart codes. And also from there in the Vaasa, they have this kind of craft brewery who is involved in the pilot, and the beer is there, the product in the cereal chain. And then from Hämeenlinna, Häme Vocational Institute, it's like a local dairy school. They are involved in the dairy chain, and they are involved in some premium cheese products in this pilot. And then VTT Technical Research Center of Finland, we are also involved and also have been developing the technologies here and organizing the pilot. So I will briefly tell to you about the objectives and expected outcomes, the solution, the functionalities, and give like a general description how this tool is working and then how to utilize the system. So the objectives, our aim was to design and develop and improve traceability of high-value products in the cereal and dairy chain, and do this by implementation of a solution to track and trace items at their raw materials on item level in the food chain. So getting the information of the products already there, starting from the primary production and the different steps when the raw materials are entering to the processing plant, and then finally through retail to the consumer. And the solution is an item level track and trace solution which we can utilize to track and trace items and the raw materials on product level. And it can also act as a call for action for consumer interaction with the consumer. And aim is to verify the quality of the item, authenticity and shelf life, for example. And this cannot be utilized as a farm-to-fork two-way communication channel also. So the functionalities that this tool has, there are track and trace. Aim is to track and trace products and raw materials through their life cycle, and also engage consumers directly with a true two-way communication channel so that they can verify the product authenticity and shelf life, and also give for the manufacturers a quickly contact way how to contact consumers in case there is a product recall, for example. And we are also building an other layer for the food control authorities so that they can also get additional information of the products. And aim is to get like a batch specific information, not only about the manufacturer and ingredients used, but also about the manufacturing conditions and methods. So give like a wider view of the product and the story behind it. So in this case, the products are marked with unique smart code, and they are managed in centralized database, and the information is processed and displayed at the production batch level, but if necessary, it can also be done at individual product item level. And so the system is working with a smartphone, and actually what consumers can do, they can scan this code here, and through that they can get additional information of the product. For some new iPhones, for example, you need to upload this upcode app so that you can read this code, but for Android system it's working, and also for the new versions of the iPhone it's working well. But here is an example now what you will see when you read the code, and especially when we want to prevent counterfeit, we have an additional layer here. So if the product has like this kind of tag, for example, in the cheese, it can be utilized to increase the authenticity and like prove that the product is not copied. So if you scratch the PIN code underneath the sticker, you will get a code which you can then enter in to the app, and then you will get additional information of this specific product and get like a guarantee that it's a genuine product made by an authorized manufacturer. But in the case of consumers, what are the things that can be seen here? You will see product information, and when the authorities, they have an additional sign-in option, and they will get even more detailed information of the processes this information is not visible for the consumers, but this special category can enter in and deep into more detailed information. So in the case of consumer, you can find information, for example, of the ingredients, production process, and also like a video of the cheese making, for example. And in addition to that, there is information related to from which area the raw materials are coming from, and of course information where the product has been manufactured. And this is information that is related to the batch and even to the item. So you can see information related in this case, for example, to the cheese packets, that when it has been, milk has entered to the dairy and how it has been processed there. And in case of the authorities, one example of the more detailed information that they can see is, for example, the pasteurization curve, because in dairy it's critical to pasteurization is a critical step, and there are criteria that how high the temperature needs to go. And authorities can also find additional information of the ingredient providers and their quality systems. And this tool is also like a two-way communication channel. So the consumer can give feedback. They can, for example, there can be some kind of surveys in it, and they can give feedback, for example, of the taste, price, quality ratio, information of the feedback on the information provided in the application. And in this case, we have also asked whether they feel that this solution has increased their assurance in safety and authenticity of the product. And they also have another option to give feedback where you can write like sentences and say open feedback. And in case that, for example, there is a need for product recall, then the manufacturers can quickly update the information in this app. And when the consumer is reading the code, he can see that, for example, that don't eat it, this product needs to be recalled. And they know then that they need to discard or return the product to the shop. But this was very briefly our part. And in the end, I would acknowledge all the people who have been working here in the app code. Pekka Karhunen, Jari Isohanni, Niko Mattila, and Studio. They have been involved in the development of the smart code system. And of course, the people who are working there in the brewery. And Jari Ilatva-Koivisto and Johanna Hau ja Evelina Järvinen in Häme Vocational Institute. And Liisa Hakola, Pekka Koskela, Sirpa Nuutman, and Anu Vaari at VTT. So currently the beer cereal chain product is done there in Vaasa, and the cheese is there in Hämeenlinna, and they are currently being sold also there in 2 locations in this brewery shop, and in Hämeenlinna there is a vineyard shop where they are also on the customers can buy them from there. And here's an example of the products that we have been selling, and this is ongoing until end of this year, this pilot. But thank you very much.
Thank you very much, Hanna-Leena. It's been a pleasure to hear all of the work you're doing in the Watson project. But please don't go away, because we'll be coming back with a few questions for you after the other 2 presentations that we have in store for the listeners. I can already see some questions coming through the chat. Just a reminder, if you do have a question for our speakers or about the Watson project in general, then please do add it to the chat. If you can specify who it's for, then that's absolutely great. Just as Dimitrios has said, my name is John Switters. I will be taking over the moderation now. I work for the Lisbon Council, which is an organization based in Brussels. And we are working on the Watson project in the communication and dissemination work package. So my first job this morning is to present our next speaker, Pedro. So Pedro, please come to the floor, who'll be giving us an insight into the Portuguese wine use case. Take it away, Pedro.
So, hello everyone. Thank you, John, for the introduction. So, as John said, I'm a senior researcher at Inesctec, which is leading this Portuguese wine pilot in the Watson project. For our work, we count on the collaboration with our most valuable partners, which include Synelix, CERS, Netcompany, Advid, which is a collaborative laboratory in the wine sector. And while not a partner in the project, we have also counted with Sograp, which is the Portuguese main wine producer and exporter, to give us in-depth knowledge of the sector. So when we kicked off, it became quickly relevant that traceability is a major issue for the wine sector. So traceability here means to have objective, accurate, reliable, trustworthy knowledge of all the processes and all the sub-products up to a certain point where we want to tell this story. So what happened? What took place until the point that we are observing? And this has two main perspectives. We can look at this from the end consumer point of view, where consumers are becoming increasingly aware and concerned for certain factors like carbon footprint, the origin of the product, if they were biologic treated, if there were pesticides. So this has an impact on the brand, on the trustworthy of the brand, on the recognition, which means that having this information associated with a product can increase its value. But it also has a perspective for other stakeholders. This is other institutions, entities, people along the value chain, by giving them increased knowledge of the environment and on the processes. Not knowing the full process means that you may have inefficiencies, you may have loss of revenue, you may have disruptions. Given this, it implies less margins and less profitability. So traceability can have these two aspects, both relevant. Indirectly, so it's not the purpose of the pilot, but indirectly, we can also help in public authorities. Currently, there are control checkpoints, but they are usually done by sampling. By providing more information on traceability, it means that we can act as a deterrent and also help flag potential situations. So just as a quick illustration, last year, a news here in Portugal means that our food safety authority was doing inspections to detect illegal transportation of grapes, especially those coming from Spain. So here there was a big concern knowing where the grapes were coming from, so that we know that the products that were being used to produce the wine were actually from what we call the dominated regions, which means certification. And curiously enough, this week, actually the day before yesterday, another news where we had also inspections on wine coming from Spain. And the concern here was not to see if there was any fraudulent activities, but especially knowing what was the course, where the wine was coming from, where was it going. Again, the idea is that for the food safety authorities, they wanted to know the traceability of the product. So these two news 1 year apart, but in a very special time of the year, which is when the harvesting are occurring and the wine is being produced, highlights the importance of traceability. So what are we proposing here in terms of the project? So we started looking at this at especially the early stages of the value chain during the grapes and the harvesting and the wine production, because we cannot start building this type of traceability from the top. So as build a house, we need to have good materials and start building from the foundations up. It is true that there are different stakeholders already with some traceability processes in place, but these are limited and typically close on their own institution. So we put here our effort in helping improve the traceability since the growth of the grapes up to the harvesting and then the wine production. And for this, we propose a set of sensors and IoT technologies that will help monitor all the environmental conditions in the vines through time. Also sensors to monitor the harvesting process and their transportation, as this is typically a vulnerable place. All of this only makes sense if we can use this data to information and knowledge. To do so, we have been putting in place an interoperability layer, enabling all these different technologies to work together, and then store the information reliably and trustworthy in a blockchain platform, and then provide to the different stakeholders a view on the knowledge and on the information through a digital food passport. So the value chain is quite complex. We have a lot of different actors involved. As we are focusing on the early parts of the value chain, so the grapes, since the part they are growing, their transportation to the trucks and from the trucks to the cellars where the wine is produced. And this is where we are currently stopping the monitoring, only also for logistic reasons. Technically, this type of sensors that we are using to monitor can also be applied for long-term transportation and storage. But the idea is not to replace all the processes that are already been used, for instance, for the retailers, but to combine. And to be able to do this, we will need to have an interoperability and blockchain platform covering different stakeholders or integrating information coming from different stakeholders, because only in this way we will be able to reliably and trustworthiness tell the story, what happened to the product and these constituents up to this point. Based on the focus of our pilot, we are working mostly here with the producer, which will be the stakeholder more interested in knowing everything that happens to the grapes that comes to his winemaking facility for producing the wine. We can have other stakeholders involved as soon as we extend this to the value chain. In the pilot, we also have a small part focused on the end consumers in two aspects. Through the digital food passport, we can also provide information about the product, so traceability information. Is the product coming from the correct denominated region? Was it subject to pesticides? Was there any abnormal environmental condition that could affect the quality of the wine? And we also have a special care here for the visually impaired consumers, where we produce a tool to help them understand the information on wine labels. So while we have a lot of technologies involved, as I said, in terms of software to ensure interoperability, to ensure that communications and data flows naturally from the different sensors to the Watson platform, the blockchain platform, the digital food passport. Here, we just present a couple of tools which are more visible to the human eye, which are being used for the process of monitoring at the farm. So on the right side, we have an environmental station that is used to measure a lot of different parameters, which includes temperature, humidity, precipitation. It can also be added with what we call smart traps that enable the identification of insects that can negatively affect the vineyards. On the left, we see two technologies. So we have a bucket and scissors. So these are a very important part of the process. The scissors enable us to identify the cuts that are made during the harvesting and correlate that cuts with the increased weight of the grapes in the bucket. So the buckets are equipped with a weighting sensor, and both the bucket and the scissors are equipped with geolocalization. So this is a huge improvement in terms of monitoring and contributions to traceability, as we no longer use information at the parcel, so a large portion of the vineyard, but we can have traceability up to the actual or individual plant. And by using this geolocalization, we can know where the grapes were captured, where they would put on the bucket, and the full path that the bucket did during transportation to a larger container, an example that we can see here in white. So this process continues, and we also geolocalize these larger recipients. So the grapes are dumped into these larger recipients, and eventually, in some cases, also to these ones, even bigger ones for transportation. So all of these containers are also geolocalized, and they have sensors to measure, for instance, the temperature. So this gives us a clear view from the plant where the actual grape was harvested up to the wine-making facility. Also, this has a lot of benefits. For instance, we can know what were the paths taken, and this, in conjunction with the early warning system being developed in Watson, can flag potential fraudulent activities or attempts to adulterate. We can know if we are following the most efficient route, which means on one side, the grapes will not be exposed to too much heat, which damages the wine. And on the other, we can also help decrease the carbon footprint. We can correlate the weight of the containers from the plant up to the winemaking facility to make sure that the weight was maintained. So again, help control the full process. We have not got into the winemaking facilities because in some cases, they are already making full traceability at the winemaking facility. One particular thing that we are trying here is to have this type of equipment to be flexible in the sense that it's easy to use without being disruptive to the process already in place. For instance, in the harvesting, the harvesters are using the secateurs and the buckets that they already use. So we just equip them with sensors. And we're trying to have them cost effective in the sense that it will be easy for different producers and farmers to adopt this kind of technology. As I mentioned, we also add a small app focused on visually impaired consumers, where we help them not only distinguish the type of wine that is in front, but looking upon the bottle to provide a set of information to help them know what the product that they are consuming. So putting this into value chains is a highly complex. It's not easy. The winemaking value chain is ancient. It has a lot of tradition, so it's not easy to introduce this type of digitalization. We also have an heterogeneous set of entities with very different economic and financial capabilities to adopt this kind of technologies. And it is impossible to have traceability if we have gaps in the value chains. As an example, Some wine producers may have their own farms and they can acquire the technology to monitor and improve traceability in their farms. But a significant part of the grapes that they use come from what they call integrated producers, so other farmers that sell the grapes. If these farmers do not introduce also that technology, and all this technology does not fall to a common platform to give us this holistic view, then there will be gaps and we will not have true traceability. So it will be important to not only integrate technology that we are currently developing with the systems already in place and their processes, but also to extend this technology to all the stakeholders. And this means that we'll need to ensure interoperability between all these technologies. So the layers that I've mentioned about the interoperability and the blockchain is core so that we can have these two traceabilities. All the sense equipment is just providing data. It is up to collect this data in this interoperability layer and the blockchain to produce information and then knowledge that will enable the stakeholders to increase the value of the products or to act to make their process more efficient. And in this case, we have here two major issues. How can we get all these different stakeholders to cooperate with each other? Should we use a single interoperability layer and blockchain to store all the information across the value chain? Should we have more than one? And also, there's a cost issue. Putting all these technologies implies a cost. This cost either is reflected on the end product, which increases the cost, the price of the product, or should be translated into a gain in terms of efficiency of internal processes. If we cannot have this balance, we cannot convince the stakeholders to adopt all these technologies. Right? So, thank you for your attention. I hope you have enjoyed this short presentation.
Thank you very much, Pedro, for your presentation and for showcasing all the work you're doing as well. Actually, as a project we were very lucky and we got to visit the winery and see some of the technology in action. And I just wanted to add as well, it's extremely nice to see that accessibility is being taken into account on the technologies that you're using. So a big congratulations for that. Okay, Pedro, again, we'll come back to you at the question and answer. I can see some questions already coming through on the chat. But for now, I would like to invite our third and final speaker to the floor, Truls, who will be giving an overview of the work they're doing on the white fish use case. So, Truls, when you're ready.
Yes, thank you for the introduction.
Truls, sorry, just quickly, we can't quite see your face. If you'd like to move forward a little bit to the screen, I'm not sure if you can. It's just the light.
It's backlight, which is kind of poor.
No worries.
Okay, thanks for the introduction. My name is Truls Bakkjoreda. I'm a senior research scientist at SINTEF Nord, which is a Norwegian research company located in northern Norway. My role in this project is to be leading the whitefish pilot. So we've called this talk the Combating Whitefish Counterfeiting. I want to do a bit of a slightly different take on this type of talk. Some of you might have seen other webinars where we have talked more about the technology. I wanted to go a bit more into the motivation and kind of context of the pilot itself in this talk. Also because I think there are some in the audience from the general public which might not be experts on all the technology. So it's also good that Pedro has explained quite a bit of the technology already. I'm trying to kind of argue from, maybe call it first principles. We want to have sustainable fisheries because the food that we get from the ocean is vital for the food security in the world. Sustainability is, as many of you might know, often described in three different aspects: social, environmental, and economical. And within these, you can kind of put more subcategories. This is not meant to be exhaustive, but kind of mentioning some of the important parts for the fisheries sector. So under social, you have labor conditions. There is still actually debt slavery in the fisheries sector in different places in the world. And it's vital for food security. It has to do with the environmental sustainability through climate, the inputs to fisheries, of course, like fuel and other things. It consumes products and fuel that contributes to the climate change. There could also be spills like oil spills or waste spills from fishing vessels and other types of vessels. But the thing I want to talk about today has to do with stock management, meaning that we should not fish more of different species than is able to be replenished naturally. This also has to do with bycatch management. You shouldn't catch fish that you're not allowed to catch. If you're fishing for cod or saithe or haddock, for instance, you should not take other types of fish. There's also a big question regarding ghost fishing and gear management. If you leave your nets in the ocean and the nets are not properly designed, they will catch and kill fish for decades after it has been lost. And of course, there is the question of economy. If people break the law to catch fish, then they are getting an unfair advantage over fishers that actually follow the law, meaning that they will not be able to compete. So in the fisheries sector, we have this expression called IUU, which is illegal, underreported, and unregulated fishing, which is kind of the big problem. I'm just showing you a simplified fishery supply chain. You have the fishing boat. In the case of the whitefish pilot in the Watson project, this is a trawler, which is quite a big vessel. It can store up to 450 tons of fish on board before it has to go back to harbor to unload the goods. Then follows a cold storage. There is a transport and distributor is mixed. So there's a transporter between the cold storage and the processor. Then there's a distributor into wholesale or retail, and then you get to consumers. And I want to highlight a bit kind of what the different responsibilities of each of these actors are when it comes to ensuring the sustainability of this industry. So what goes into stock management in order to ensure the sustainable fisheries? You kind of have to assume that we have both comprehensive and reliable research on fish stocks. This is to be able to set quotas that are sufficiently high, but not too high so that you deplete the fish stocks. But of course, it's not enough. You need to have political willingness to actually adhere to this advice, which then should be based on scientific evidence, both when setting quotas and negotiating international trade deals. I'm, of course, based in Norway, so we deal with Russia, UK, and EU a lot when it comes to these trade deals. Norway and Russia has a long history of collaborating when it comes to the fisheries quota management, which means that since we share quite a lot of areas in the ocean where both nations fish, we need to have good cooperation, even though there is a tense geopolitical situation today. And this, as far as I know and understand, this still is working well, and that's good news for the fish stocks in the northern Atlantic. Moreover, fishers need to respect quotas and report catches. This includes species, quantities, catch gear, area, and period. You have authorities that monitor and control catches, landings, and the documentation. You have middlemen like traders, storagers, transporters, and others that maintain the chain of custody and integrity of not just the physical assets, but also the documentation along the supply chain. As Pedro mentioned, this is one of the places where we have challenges today. A lot of the information that is being generated and exchanged, they're only exchanged one step forward and backwards, which means that if you are a distributor, you might not get the exact information that, for instance, a freezing storage created. Then you have the processor. This is where most of the processing of the raw material happens, of course. They need to both control the quality, maintain a chain of custody, and create new product information that ultimately the consumer will see. In the case of the whitefish pilot in Watson, most of the raw material that is processed by our processor, they actually arrive at the factory as headed and gutted fish, which means that you can recognize whether or not the species has been replaced, for instance. The people that work in the factory, they're trained to recognize if a fish that should be caught is tilapia, for instance, or any other type of substitution, and that will be caught within their processing plant. Furthermore, you have the distributors and the wholesale and retailers that also need to maintain chain of custody and the quality of their product. And of course, finally, you have the consumers. I think this might be a bit underestimated, but the consumers are the ones that need to hold supply chain actors and authorities accountable so that they kind of perform the tasks that they need to perform. So I think the goal of the Watson Whitefish pilot can be summarized quite briefly as to present the consumer with reliable data on the product. And this kind of situates us within the sustainability of the fisheries pilot and the sub goal of stock management as kind of living in the middle of those points. And the way we do this is that we work to create sufficiently detailed documentation of the origin and chain of custody of the raw material from catch to processing. That's the first step. So there, at that point, we kind of stop just before the processing step, and we want to assure that the processor gets all of the information that they would want. And then the next step is to combine the data from point one with the data that is being generated in the processing stage, and ensure that this is shared with the distributors, retailers, and then on to the customers. There's also an early warning system that will help authorities flag potentially suspicious fishery activities. And I can maybe already, I saw one of the questions being asked to both Hanna-Lena and Pedro. The big challenge when combining data from the processing step is exactly this challenge of mixing going on. In this pilot, and we can talk more about this afterwards, the way we get around that problem is to create one line of products that actually only uses raw material from a single supplier. So we're going around the problem, we're not actually solving the mixing problem. There are many things I could say, but I think it's better if you ask any questions if anything is unclear or if you want any more details. I think we only have 15 minutes left for questions and comments and discussion. Thank you.
Thank you very much, Charles, and thanks for your different approach to the presentation. That's always nice to see. I would like, as we've got 15 minutes left, as Charles mentioned, we like to keep the webinars short and to the point, but also allow the audience to ask questions. So we've received some via the chat. We've received some during the registration process. So what I'd first like to do is to invite our speakers back. If you could put your cameras on, and we'll bring you back into the spotlight so we can see you. And then we'll get going with the questions. So I think as Charles has already kind of advanced one of the questions in the chat, it might be good to hear from the other two use case pilots. So how do you address the traceability issue related to mixing the product from multiple different sources? So, Hanna-Lena, if we start with you.
Yes. Yeah, as also Truls mentioned, it's in many cases, like in fish and dairy, where there are large volumes moving around quantities of the product. It's always the problem, but also in this Watson pilot, we have been now working with like a little bit more artisanal products that for example, in case of the dairy, the milk has come from the local dairy and they have a good traceability system, so they know where it's coming from. But I think also, like Truls mentioned, the only option would be like to have these special batches that you have only milk coming from the one farm. Then in that case, you can really truly say that that is the origin of the milk. In case of the beer and the malting, there it's more easier because the quantities are there also a little bit smaller and the farms are rather big and a lot of cereal coming, each of them. So you can quite easily trace back that from which farm the malt, for example, is coming from.
Thank you very much, Hanna-Lena. Pedro, I'm not sure if you have anything to add to this question with regards to your use case.
Well, the wine probably is a special case where in some of the wines, it's supposed to be the mix of different types of grapes. So the question is not so much to prevent that mixing, but we need to know where the grapes involved in the winemaking process came from. At the winemaking facility, they have a registry of these things. So they buy the grapes from producers when they don't have self-production, and they know in the containers where they ferment the wine, the grapes that were used. The process or the problem now is, how can we objectively, accurately, and reliably know that the grapes that arrive at the winemaking facility, where did they come from? And this means that this technology that I presented, that we already tested and demonstrated at vineyards from Sograp, which enables the localization, the traceability from the plant, not the parcel, but the plant up to the winemaking facility, that we can extend this to their integrated producers, so the ones that sell them the grapes. If we can do this, then we can have this full traceability and know for a wine what was the plant that the grapes came from.
Thank you very much, Pedro. We've also had a request, another question from the chat, and that is to Hannah. And that's, can the origin of the cheese be determined before the cheese is purchased? And the person who's asked this question said, if they've understood correctly, the scratch part is in the package. So you cannot scratch it before you buy and open the product.
Yeah, well, the smart code you can read already in the shop, and that don't need to be scratched. But this scratch part was like an additional feature that can be included in the package if needed. But already the smart code itself, it's having a lot of information, and this is just like an additional hurdle for the authenticity.
Thank you very much, Hannah. We also, in the run-up to the event, we actually received a couple of questions in the registration form. We left that open to the participants. So I've got one here. Let's see if it's kind of a bit of more open question. So see if any of our speakers can answer it. And that is, are there any EU-led initiatives or open access platforms that supply or building or technology transfer for food fraud detection in regions of Africa? For example, in Ethiopia and other East African countries. Sorry, that support capacity building was the question, sorry, or technology transfer. For example, in African countries such as Ethiopia, on subjects such as milk adulteration. I'm not sure if anyone is aware of this or has any idea on this question. If not, we'll endeavour to ask the consortium and get back to this person with the knowledge we do have. Would any of the speakers like to add anything on that one?
Well, I'm not aware of a particular platform that could be used, but I know there have been some calls and some projects aiming specific to some African countries, so application of technology to these African countries. Nevertheless, the idea that we're exploring here in Watson, it's not EU closed, in the sense that we intend this technology to be democratic and used by different value chains, different stakeholders, different countries.
Open to be used by in different applications. So that's great. And we will also reach out to this person who asked the question just to get back to them with what we have on that. We have another question that came through, and that was, what rapid on-site tools or field level screening methods are available for detecting such adulterants? I'm not sure if anyone has any replies to this.
Well, here we have to be careful in the sense that the question had to do with if we can detect fraud on site. This is kind of tricky because in this case, only food safety authorities using certified equipment can say that there was a fraudulent product. This type of equipment, often lab-based. In Watson, what we try to attempt, and we have different technologies depending on the food product and depending on the value chain, but what we are trying to do is to provide screening devices, which in the future can be certified and even used for fraud, but that requires a somewhat long process. But to have these screening devices to help, on one hand, provide additional data and knowledge of what is happening, and on the other, try to flag some anomalous situations or anomaly conditions, or even do we think that something happened to the product and needs further analysis, but not to detect fraud on site.
Thank you very much, Pedro. And I'm going to stick with you, actually, Pedro, for another question. Are there standardized technologies or processes already in place at the grape producers?
Yes. So as I said, stakeholders already have their own traceability process. For instance, retailers have a process for when some product arrives at their storage up to the shelf, and they know when it was purchased. Not the individual product, but the lot. Producers, especially those with higher financial capabilities, already have traceability process, and they want to include more digitalization, more automation in this traceability. Okay? So there are still limitations, there are still gaps, which we can contribute to fill, but yes, they already have something. And one of the concerns that we want is to, with this interoperability layer in the blockchain, is to make sure that we have a way to integrate what they already exists with what we are trying to introduce.
Thank you very much, Pedro. And now jumping over to Hanna-Lena, we have another question that's come through, and that's, can the smart tag solution be applied to other products?
Yes, it can. And the aim is that it can be applied also to other products, but you just need to then collect the information of this food chain.
And I'll stick with you as well, Hanna-Lena, for another question. And that was, how has the consumer feedback been from the pilot?
Well, it has been really positive. They have been saying that it's nice to get additional information of the story of the product and where all the raw materials have come from and how the processing has been done. They say that it increases the trust to the product and to the production process, and also they feel that when they know more about the origin of the product, it improves the food safety and this authenticity feeling.
Thanks, Annalena. And I'm going to jump over to Truls actually, just with a question, a bit more of a general question. Which point in the fish supply chain are you currently detecting, or is the issue? Do you detect the issue of fraud?
That's a good question. I think one of the things that the processor has been seeing is not it's a bit indirect. So the fraud that has taken place, if I actually use the word fraud, Pedro, it's that someone claims that the product has a certain certification that it does not have. So in the fishery sector, there's a certification called MSC certification that is supposed to tell us that the fishery that the vessel or the supplier is part of is sustainable itself. So it's kind of a higher level thing that the fishing vessel is part of. And this is supposed to actually be getting a price premium. So even fishers who aren't part of that MSC certified sustainable fishery want to claim that their raw material is MSC certified to get a higher price for it. This is something that happens just before the processor, and that's why the processor has really stringent intake controls. What the product is trying to do is to kind of more or less create an industry standard that first the fishers in Norway are able to adhere to, and then you can start demanding that from also suppliers from other parts of the world that they buy from. So this is it is a pilot and a prototype of something that hopefully will get wider later.
Well, we certainly hope so, Truls. And actually, Truls was one of the stars of the series that is being created currently on the project that I'll come to in a minute. So yeah, congratulations on that. You were very good in the series there. We'll mention that in a second. Just time for last couple of questions, and I'm going to jump over to Pedro. Pedro, someone's asked, based on the pilot of the Watson project, what would be the next steps? So where's this going?
Well, I think we can have here three steps, which are not just technology dependent. One is, how can we help the technology that was developed to be adopted by the different farmers, not just the big ones or the producers with a lot of financial capability. So the idea of technology to be cost accessible, but this is a major issue because otherwise we'll have major gaps at early the value chain. The next one is at the current states to actually integrate the information that we are producing with our sensors and integrating in Watson to be interoperably connected with the process already in place in the winemaking facilities, so the producers already have in place. And the third one is, how do we expand this to other stakeholders along the value chain? So starting from the producer towards then consumer. And here we have major interoperability issues. And also a question that is hard to answer is, where do we stop? Ideally, we would like to go to the end consumer, but is that feasible? Where does this traceability stop so that we can justify this investment from the different stakeholders?
Thank you very much, Pedro. And thank you to all our speakers today. I think you've been able to transmit a lot of information, a lot of interesting information about the work that's being done in the project in a very short amount of time. So if anyone has any further questions, then please send us an email. You can contact us via the Watson website. I'd just like to mention that one of our audience members has put a suggestion for open data source by commodity and country, useful resource in the chat. I think that was in response to one of our earlier questions. So thank you very much for that, Grace. And as we're running out of time now, I just want to flag the next webinar that we have that will cover the other remaining use cases that we have in the Watson project. So that will be on Friday, the 24th of October at the same time from 10:30 to 11:30 CEST. And that will cover the honey, olive oil, and meat use cases. So please, soon we'll send out the registration and we'll make that available and send that through to you. And then just before we go, as I mentioned earlier, Charles is one of the stars in the current series that's actually airing on Euronews. It's called The Food Detectives, and it does a deep dive into each of the use cases that we have in the Watson project and provides a little bit of a background in a very visual and entertaining way. So I encourage you all to visit the Watson YouTube channel, and the episodes will be made available there as and when they come and they're aired on Euronews. So I'd like to congratulate the team for the work on that as well, and for all of the stars of the show. So without further ado, I'd like to say thank you for joining us and giving us your time today. And we look forward to seeing you at the next Watson event. So thank you very much and goodbye.